Let's explore the implications of applying Newton's second law of motion to the kinematics of uniform circular motion. Uniform motion in a circle implies that tangential acceleration is zero, indicating that the angular velocity remains constant. As the object moves from point A to point B, the tangential velocity changes direction but maintains the same magnitude due to the constant angular velocity. The position vector of the object R shifts from position RA to position RB, rotating by an angle delta theta. During this transition, the object covers a distance along the circle delta D with the net displacement delta R. When the rotation angle approaches zero, the distance traveled delta D and the displacement delta R become equivalent. Recognizing that a tangent with a radius forms a 90-degree angle, velocity VA forms a 90-degree angle with radius RA, and velocity VB forms a 90-degree angle with radius RB. Consequently, following the rule of equal angles with perpendicular arms, velocities VA and VB also form an angle delta theta. The third side of this triangle, delta V, is the difference between vectors VB and VA. Since radii RA and RB are identical, we denote them both as R. The same applies to velocities VA and VB. Triangles OAB and O1A1B1 are isoscale triangles. Additionally, due to the equal angle delta theta, they are similar. The ratio of sides in one triangle equals the ratio of corresponding sides in the other triangle. Delta V over V equals delta D over R, implying that delta V can be expressed as V over R times delta D. Dividing the entire expression by delta T, we find that delta V over delta T equals V over R times delta D over delta T. The initial term is acceleration A, directed towards the center of the circle, aligned with vector delta V, and the final term corresponds to the tangential velocity V. This implies that the magnitude of this acceleration is V squared over R. This is centripetal acceleration. Centripetal literally means seeking the center in Latin. As per Newton's second law of motion, every accelerated motion must be caused by a force. This implies that even uniform circular motion, because of centripetal acceleration, must be induced by a force. This force aligns with the acceleration and is recognized as the centripetal force. In nature, there must exist a genuine source for this force. In the scenario of the Moon orbiting the Earth, the gravitational attraction between the Earth and the Moon is the centripetal force. This centripetal force consistently bends the Moon's trajectory, which, as per Newton's first law of motion, opposes it, resulting in the emergence of an inertial force which can be observed in the orbiting system, the Moon. This inertial force is known as centrifugal force, with the same strength and direction as the centripetal force, but in the opposite orientation.